your money with tuition. You are not put in the effort. Basically, I see the problem is you are not putting in the effort. No effort, you can't get anything. You must put in the effort. It's just like the gardener. He has to put in the effort, or the farmer, to plant the crop. Then he can get the harvest. No shortcut to that. So same, if you want to do well in physics, you have to put in the effort to learn.
Okay.
Your whole life is like that. You have to put in the effort. Whatever you want to do,
You want something, you have to work hard for
yeah,
it.
you have to work hard for it. No choice. You'll find the pressure will be on you as you go further and further. No shortcut on. That's what life is all about. Only when you retire after working hard, then you enjoy it a little bit. Okay, let's go to resistor in series and in parallel. Right? There's a lot of homework for you to do. Okay, resistor in series and parallel. Are you ready?
Yeah.
Okay, there's your resistor in series. Look at 3 of them. Right? The total resistor, you just add them up, R1 plus R2 plus R3. So there is your cell. Right? EMF is V. Usually we won't bother about the internal resistance. Right? We look at 3 resistors, R1, R2, R3. There's a current there. Current through each resistor is the same. That's the first thing you need to remember. If it's in series, the current through I1, I2, I3 is the same. All I here, I here.
Tell me again, sir.
The current through resistor R1 to
Okay.
resistor R2 to resistor I3 is the same. That's what it says all here. Right? Because it's just
So the current throughout the resistors are the
it
same.
doesn't go anywhere. Their voltmeter are all ideal. Ammeter also ideal. So no current flowing through the voltmeter. So the current only flows through R1, R2, R3. That's all. Okay. Can?
Okay, let me get this straight. It only flows to the voltage one only. I mean to the V1, V2, V3, but it does not flow V1, V2, V3, but only to the resistor,
It
right?
only flow through R1, R2, R3. And since your voltmeter is ideal, voltmeter doesn't draw any current. The ammeter ideal, ammeter doesn't have any resistance. Okay. So let us just show you Kirchhoff's voltage law to derive the equation, right? Which is conservation of energy. Right? Let's just derive it. As we say, is Kirchhoff's voltage law is conservation of energy. So let's show it. Right? Rate of energy supply. Right? Energy supplied by the battery because the energy loss here, energy loss here, energy loss here. Or we call it dissipated in each resistor. And right in equation form, that's your current I. So I, there's one supply, V times I. Dissipator is R1 times I. Sorry, V1. Right? That's your V1 here times your I. V2 here times your I. V3 here times your I. Okay. Or if you want, you can use straight away I squared R1, I squared R2, I squared R3. So you can cancel the I. So we get, that's your Kirchhoff's voltage law. Right? That's your sum of EMF. There's a sum of potential difference. Kirchhoff's voltage law. Okay with that? Yeah,
wait. Okay, so conservation of energy, rate of energy supply equals to rate of energy dissipated. That means it flows throughout the resistor and then it also loses it lah.
The
Right.
resistor is where it lost energy. Supply is the battery.
So it's before and after.
So the one supply is the battery. The one dissipated
Okay.
or lost is in R1, R2, R3, that's all. Emitter doesn't have resistance. That's what it means by ideal. Okay, can we go another slide? Can go back and read. Go back and read. Okay. Okay, we have derived for you Kirchhoff's voltage law. Okay, so what we want? We instead of 3 resistors, we want to replace it with the same voltage source, V, and the same current. But instead of 3 resistors, we replace it with 1. RT. Okay? So instead of 3 resistors, R1, R2, R3, we replace it with RT. RT got different name. Some will call it combined resistance, some will call it total resistance, some will call it equivalent resistance. Okay? The battery is the same. Battery is the same, we didn't change. The current coming from battery is the same, we didn't change that. Okay, so the main thing to remember is that is your V1. So V1 is proportional to R1. That's what this equation is saying. Right? If R1 is largest, then V1 is the largest. Or if R3 is the largest, then V3 is the largest. That's all. Can? Instead of thinking
Oh, that means R1, R2, R3, we can replace it with one only lah. Total
one only. That's what it means by replacing one with a total resistance or combined resistance.
Yeah, but what if there's two different currents?
Where got two different current? The current is the same.
I'm asking.
Where got two different
for
current?
series is the same lah.
Series is the same. We have already said to you already. Current through R1, current to R2, current to R3 is the same.
Yeah. Oh, it's a fixed one lah. Okay. Okay.
That's what I mean by series. A current is the same. That's why you do your experiment in STPM to show that the current is the same in R1, R2, R3. Okay. Right? So RT we can call combined resistance, can call resultant resistance, we can call equivalent resistance. These are all the same thing. Different name that's used as well.
You go back?
It's all in your note. Why is there? You want to go back? It's a waste of time.
Okay. Why are you getting angry so fast lah? I'm learning, right?
No, learning you must download it. That's how you learn.
Okay. You can go next one.
Right? That's where we come to Kirchhoff's voltage law. So replace it with the current times the resistance. Right? So V is I times RT. That's why. Then I times R1, I times R2, I times R3. That's why it is. So cancel the I. Then you get your series formula. RT, you just add all of them up. R1 plus R2 plus R3. Okay. Yep. What's the problem?
No, okay.
Right? You have derive the resistance formula for series. So let's go a little bit more. If all of them the same, right? 3 of them the same, then we just times 3. Right? If it's n of them the same in series, n times r, you find that when it comes to STPM, it's better you can remember this formula. Then you can do it faster. 3 in series, total is 3R. That's all. N in series, each of them are, total is NR.
So 3R.
Right? And the total is always greater than any of these. Because you add all of them up. Can?
Can.
Okay, let's go further. Right, what's the answer for this one? SPM work.
What is the resultant resistance? Okay.
Right, simple question. You won't get it in A level.
6.5 K.
Just add all of them, good. Add all of them, 6.5 kilo ohm.
Yeah.
Okay, let's go to resistors in parallel. Right, there's our source of EMF, V. There's a current coming out, I. It branch to I3, I2, I1. Resistor is R1, R2, R3. Right, that's the formula we want to derive. PD, how do you know it's parallel? The PD across each resistor is the same. PD across R3, R2, R1 is the same. Current in each resistor is different. Right? This current, I3, I2, I1 are different. That's what it means. Parallel. Current from the cell branch out to a resistor. That's a current. Right? It branch out to I3, I2, I1. These are all different branch. Okay, so since this is the source I, you apply Kirchhoff's current law. You got I equals to I1 plus I2 plus I3. Okay, and then remember, you want to calculate your V here is just your I3 times R3, or your V here is I2 times R1, or your V here, potential difference, is I1 times R1. That's what this formula means. Right? So you have to read that this is parallel. Right? Or sometimes they may draw it this way, easier to see. Right? I coming in, branch out I1, I2, I3. Right here. Coming into the point, go to I3, then I2, then I1. Right? So we are going to replace these three resistors with one resistor. And the current is the same. This current and this current is the same. The battery is the same. Okay, so far? Can we go to the next slide?
Wait, potential different, same, current different. Okay. Current. Okay. They can campur lah.
We just replace these three resistors with one. That current and that current is the same. The power supply cannot change, still the same. That's what it means by equivalent circuit. Yep, can?
Wait, you say I1, I2, I3 is different, what the current?
Yeah.
And then why the down one they show they campur the current?
This current, this one, this is your I, this is your I.
Comes
out, it branch to I1, I2, I3. That's why it branch. Right? You have to be
that's what I'm trying to tell lah.
that this one is the same as that one.
So is I equals to okay, now I understand. That means they divide.
Yeah, this
they
I3,
just break it down lah.
This I2 plus I1, then branch to I2, then this one go to I1.
Basically that means they branch down lah.
They branch out.
Okay, now I get it. Okay.
Right? Usually if it's drawn this way, it's easier to see. Right? It's drawn this way, but it should be familiar. This is the same as this one. Okay? This one is easier to see. Yeah? That's your V.
Okay.
That's your I1, that's your I2, that's your I3. Same thing. Right? And this one is called a branch. Okay, so instead of seeing it as three resistors, we want to replace it with one. Battery is still the same. Right? That current is still the same. That current is still the same. Then change. Here we want to determine the combined resistance. Right? Instead of thinking of 3, we replace this 3 with 1. That's all.
Yeah, back again. Okay, can go provide the same current. Oh, wait,
That's what we
provide the
want.
same
That's
current.
what equivalent circuit is all about. You cannot change the battery. You cannot change the current coming in or going out. It must be the same.
Yeah,
Only the one we
I mean,
replace is 3 resistance.
I mean the current can branch out lah.
Yes,
Can
current can branch
produce
out.
different. Resistance is the same lah. It's just total only.
That means you replace that 3 resistance with 1.
Goes to similar to current also lah.
Right? So usually we will think of the cell as negligible internal resistance, and you will supply a current I. That current I. PD across each resistor is the same. That's important to note. Right? And your I branch out to I1, I2, I3. So that's your I coming out, going to I1, I2, I3. Right? And then we calculate our I from your potential difference divided by R. Okay, that's what we do. I, yeah, from this equivalent circuit, V divided by RT. What we get? I1, is your I1, is your V divided by R1. Right? I2 is this one. I2 is your V divided by R2. I3 is this branch. It's just your V across there divided by R3. Right? Can cancel the V or divide by V.
Yeah,
Then we get the
all the
answer.
V are the same one. I mean the V is the same one, right?
Yeah. Can?
Oh yeah lah, RT equals to R1 plus R2 plus R3. Oh, now I see where
current
you
law.
It's basically I equals to V over R. That's why you're deriving it lah, right?
Yeah.
Okay.
Right? So that's your Kirchhoff's current law, this one. So effective resistance is always smaller than the smaller resistance. That means if R1 is the smallest, RT will be lower than R1, no? Right? If it's n of them, each of them the same value, then we divide by n, no? Memorize this formula easier. Other terms used is equivalent resistance, total resistance. Okay, for 2 resistors in parallel, you can use reciprocal formula, but it is easier if you use this formula. Right? That means the top there is a multiply, bottom there you plus them up. Faster. Right? R1 times R2, bottom is R1 plus R2. Right? Usually we want to do very fast. Objective don't give you time. Okay? Can? We are finishing soon. Okay,
Where are
these are all your SPM.
R1 times R2 equals to, I mean over R1 plus. Oh yeah, okay.
Okay, faster if you can remember that. Right? Or you can use this formula. Same thing. You'll get the same answer.
Yeah, I kind of prefer the other one.
That is faster if you use this one.
Same thing lah.
Okay, what's the answer for this one? Give you the simple one to solve your SPM work. R1 is 10 ohm, R2 is 20 ohm. What's the combined resistance? Total resistance in parallel. Yep.
$20 over 3.
20 over 3.
No. Wait. Yeah lah, 20/3 lah.
Okay, 20/3, okay. Okay, calculate this one. As
Okay,
I
go
say,
back
it's
again.
better to download the note.
I think I missed something.
Better to download the exercise I've sent you. If not, you'll get lost. What's a combined
Go
resistance
back
here?
here.
That's all.
Okay, yeah,
20,
okay.
10 times 20, 10 plus 20. You got
Yeah, that's it.
20/3, that's right.
Yeah, right.
Okay.
Okay.
Yeah. What's the answer for this one? The blank here. RP here. There's a voltmeter resistance R2. R1 is the load that you're trying to measure the potential difference across. So if the two resistance are the same, you get a combined one is 50 ohm. Right? That means your voltmeter changed that resistance already. Normal 100 already. It's just half only. How about the next one? Yep. What's the answer? Put you to work. No point in learning theory if you don't know. Yeah, just using this formula, multiply them, divide by add them.
Yeah, wait, Acha. Oh, 1,000/11.
Right? So you get 90.9. Right? The next one.
Yeah, the answer is 90.9.
Next one.
10,000 over 100 over 101, which is 99.0. 99.0.
Okay. The last one.
.9000.
Okay. So you can see that what is happening. This one, the
It's increasing.
voltmeter changed the answer completely. Right? If both of them the same resistance, I can see that that resultant one is always smaller than either of them. Half of them if it's equal. And then if it's 10 times, right? That voltmeter resistance 10 times. This one is still not close enough to 100. Right? It's still not good enough. Don't think that's good enough is 100 times. Right? This one, where is 99 is quite close to 100. A better one would be 1,000 times. Right? 1,000 times. R2 resistance must be 1,000 times greater than R1. Then this is 99.9 close to 100. Okay, but it's always smaller than R1. The smallest one. The smallest is R1. So this combined one is always smaller than the combined one. Okay. You need to know this fact. The combined one cannot
So what
be
is
great.
it trying to prove?
Just to show you that the voltmeter will change the voltage that it measures. That's all. And also try to show you that the combined one is always smaller than the smallest resistance. That one must remember. Okay. Combined one resistance cannot be larger than any of them. Right? Combined resistance is always going to be smaller than any of the component resistance. Yeah, this one, any of this resistance, which is the combined one, is less than the smallest one, which is this one, R1.
Yeah.
Okay, Ken?
So then the other one, they say the V is directly proportional to R, that one.
That one is in the parallel circuit. Don't get confused here.
This is series, right?
This one is just to show you the effect of voltmeter. And this is also to show you that the combined resistance is always less than the smallest one. This is the smallest one. And that value is always smaller than this one. The two are nearly the same. If this is 1,000 times greater, that's all, than this one. That's all they are trying to show you this exercise to get you to work through to calculate the combined resistance. That's all. Okay.
Okay.
Right. That's why you say this is almost equal to that one there. If R2 is very much greater than R1. Yeah, as long as it's more than 1,000 times, yeah, okay. Quite close already, good enough. Okay. That's the reason why we must have a very high resistance for our voltmeter before we can measure the voltage across a resistance. Right? So if it's very high resistance or infinite resistance, then it doesn't draw current. That means the current will go straight through R1. Voltmeter doesn't draw current. Then it won't change the resistance of R1. Can? That's why we always say ideal voltmeter, infinite resistance. So it won't draw any current. Can or not? Anything, any problem? Yep. What's the problem?
Now, the
Yeah,
voltmeter
finishing soon.
draws no current.
We are finishing soon. Okay.
Yeah, correct lah. Yeah. Effect of
Okay,
that means when they add another one more resistance, then R2 is less than R1, more than R1 lah. Yeah.
The voltmeter or resistance must always be very large, greater than R1, before I can measure the voltage accurately. That's what this example is trying to tell you. At least 1,000 times greater.
1,000 times greater in order
Right?
to match
So the thing to
the total
remember, in
resistance and
parallel
R1.
resistors, the effective resistance, this one, is the effective resistance, is closer. This value is closer to this one.
Yeah, almost close. Yeah.
Right? In this case, it's half. If both of them are the same value. Okay, so we have completed all that. These are all the formulas that you need to know how to use. So I expect you to do your check 15.2, all of them. Okay, let's try a few questions to make sure you know if all of them have the resistance 10 ohm. A is what? What's the answer for A? Yep. All 10 ohm. R1 10 ohm, R2 10 ohm, R3 10 ohm. What's the answer? Yep. Srini, what's the answer? We're finishing soon.
Calculate the resultant resistance of each network. Okay. For the first one is
A is 10 ohm, 10 ohm, 10 ohm. In series.
yeah, A is 30. Yeah, A is 30.
That one mentally should be able to tell me 30. How
For
about B?
is 1/10 plus 1/10 plus 1/10, which is 10/3, so 6.67. Okay.
Okay.
Sorry. Yeah, 3.33. Silap, careless. Okay. Yeah, 10/3. Yeah. And then C is where are 10 and 10 plus. No. 15. The answer is 15.
Good. You can do fast. That is what you need to do. These two are 10, 10 becomes 5. 5 plus 10 is 15.
This
How about this
STPM
one?
answer.
Donkey.
Okay, 1/20 plus 1/10, you get what's that? 20/3.
Right? 20/3, yeah.
Yeah, that's the answer.
Okay, you can think about this one, whether it's series or parallel or it's a combination of all of them, right? Series and parallel. Right? You can go and think about that. Let's try another one. Okay, solve this one. Calculate the total resistance in the circuit. See whether you can get 128.8 or not.
Oh, they simplified it lah from a long one to a short
Simplify
one.
one by one. First, simplify this one.
Yeah,
This is series.
49 plus
And then this
51.
parallel. Simplify that.
And then plus with the series also lah.
Right? So combine this one. It's 100.
Yes, yes. 100. And
Right?
then the
Combine these
1/37 plus 1/45. And then you get the total one and then
Combine
plus
these two.
75.
Right? Replace
And
a
then plus
parallel one
75.
and add these two together.
Yes.
Get this one.
So 95.3.
And then these are parallel. Right? So this is 80. This is a parallel one. Okay, this parallel one.
The
Calculate
answer
that.
is 128.79. I got it.
Okay, good. That's all.
Because see what I do here, 1/100 plus 1/95.3, and then you get a 1 divide with that answer, and then plus with 80, you get the answer already.
Yeah, good. Try this one. A bit more difficult.
Okay, go back again. I missed something, I think. Yeah, okay.
This one. Right, when calculate the total resistance and calculate the current through the 3 ohm. So replace this one.
1/2 plus 1/2 plus 1/4. You get
10 RP.
you get 5/4, so 4/5 lah.
Okay.
RP is 4/5.
Mm.
And then 4/5 plus 3 lah.
Yeah. Then you find your current.
So that's the answer lah. That's for
Total
total
resistance.
resistance.
Then find your current. Right? Using this circuit, find your current, that's all. Can?
Can?
Can.
Can.
Okay, this one. Got the circuit there. You got the ammeter. That's the ammeter. Negligible internal resistance. And voltmeter. Voltmeter, you don't have to worry about the resistance, infinite. Reading on the I1, I2, V1, V2 are labeled in the diagram. Right? It's labeled in diagram. Which is the correct one? Yep.
This is a parallel circuit, right?
Yeah.
Basically. We can count the total resistance first. 1/3 plus 1/6. No. They don't want resistance. They only want I and V. So,
Okay, I think I have to review and say our time almost up. Right?
oh
This
yeah,
one is,
2 and
this
1.
one is 2 ohm. This one is 1 ohm. So it means that V1 is greater than V2. Right? V1 is greater than V2. Just look at the total resistance.
Okay, but then the I one.
Then I1, you can put a value in. Right? Put a value in to help you. But if the voltage is larger, right? Current, you have voltage, just put a value for V2 because you know that V1 is 2 times V2. Then you can calculate your I2. Then you can calculate your I1. Then you can get your answer. Right? Nothing wrong to put a value in rather than use all the maths there. As long as you work it out for this one. Can? Yep. What's the problem? First, decide the resultant resistance here.
Let's say how V2 equals to 2V.
That one, 2 times. Current is the same in here. From here, I is the same. I times R. I times R. That's how we get that.
V2 equals to 2V lah.
Should be able to do mentally. Then give a value example. You can give 2 volt, can give 4 volt if you want to. Then go and calculate your I2. Then V1, you got 2 volt here. 2 times is 4 volt. Then go and calculate your I1. Then you can get the answer.
Wait. V2 equals to 2V.
Okay, I think we will have to stop already. Our time is up already. If not, it will cut off. So I see you next week. Go and try your 15.2. Okay? You go and think about it. If you got problem, we will solve it next Saturday.
Okay. Okay, thank you, sir.
Okay.
Have a good day.
Have a good
Bye-bye.
day. Bye-bye.
Bye.